Hi everyone and welcome to this lesson on Boxplots. Before I start, I just wanted to point out that I am using SigmaXL software for this analysis. You can check them out on the SigmaXL.com and learn about their product on their website there. So for this example, what I'm going to do is just use a regular classroom exercise that I use when I'm teaching Boxplots. And let's have a look at it and then look at the data that we have available here. So let's assume that you are the Formula One director for a very well-known race team, and you're currently looking for a new racer for the next season, and one who's willing to be trained and mentored for the next decade. The table on the left side here shows the average speed in kilometers per hour of 4 racers for the same type of track, so we do a fair comparison, for the past 20 weeks. So these are your candidates. So you can see that on the side here we have in column A racer 1 with his past 20 weeks speeds based on the tracks that he raced on, and then racer 2, racer 3, racer 4. So what I'm going to do is I'm going to go up here to my menu and I'm going to go to my SigmaXL menu. So as you can see, once you go into that the software there, which runs on Excel, you will see all of the options available. What I'm going to do here is to go to Graphical Tools, and then I'm going to go down to Boxplots. So SigmaXL will bring up this window first. By default, the use data labels comes already checked, and I wanted to keep that, so that's my first row there, my racer 1, 2, 3, 4. And then I'm going to click on use entire data table, which is going to select the entire table that I have available, cell A1 to D21. Click next. The second pop-up window that I'm going to see is going to be what are the variables that I want to work on in terms of my y-axis. And because I want to compare the 4 racers, I'm going to put them all in there by simply clicking on the numeric data variables here. Now I have my 4 racers there. I'm going to keep the show mean selected, show legend, because that's important, especially if you're not used to Boxplots. And I have it add title already selected, but I was just going to show you. What I have here is just the title for my graph, which is very convenient. It will place it there for you already. Hit OK, hit OK. So just give a few seconds for SigmaXL to run the chart, and we'll have a look at it. Okay, so here are my box plots, or my comparative box plots. I'm going to make this a bit bigger here, and we can have a look at our box plot. So what I like about this output here from SigmaXL is it gives you the legend, and again, if you're not used to box plots, the median is always right in the middle of the box, so you can see by that bar there, or that straight line there. It'll show you the 25th percentile, your blue X here, we'll also call the first quartile, and your 75th percentile, or your third quartile. Recall that I checked the box to show me the mean, so I also see the mean and the median, so I have both. And then it will show you the outliers and extreme outliers. So you can see here I have one outlier here for racer 2, a couple of outliers here, and then because these 2 outliers on racer 2 here are so far from that distribution of the data set here, that the software is called an extreme outlier. So I believe that the calculation is the first quartile minus 3 and over times the interquartile range. So when I look at the box plots, I can see your 25% of the data on the first quartile here, so that's also called the box in whiskers because of the whiskers. 50% of my data sits in the box, and then up to here 75% of my data, and then the remaining. I can visually see what's going on. I can see the racer 2 is up here in terms of speed, but he has outliers down here, and I can see the racer 4, for example, it's very tight, but it's also like not a great speed in terms of racing. So if I'm the direct and I'm trying to hire a new racer for the next decade, as the exercise asks us to do, this is what I would think based on this analysis. Racer 1 and Racer 4 show more consistency, less variation. You can look at the box. Their mean and median are very close to each other, and the overall box plot is well distributed. So that's Racer 1 and Racer 4. Racer 4 shows much more tightness though in his racing pattern. Very tight, no outliers, well distributed box, very concentrated around the measure of the central tendency, the mean and the median in this case. Racer 2 is perhaps the riskiest, but he also shows the best performance of all, right? His speeds are up here. His mean and median are off though, right? Because it's being pulled down by these outliers. His outliers are quite distant from the median, and his whiskers show that the distribution is skewed. So I'm not sure. For the long term, I'm not sure about this racer. Racer 3, similarly to Racer 2, presents outliers as well. However, it could be that he has great potential, since his outliers are higher and distant from his median. So I'm wondering if this racer is being cautious here, but pretty consistent, and then in a couple of races, he did very well in terms of speed. From a long-term perspective, racers 1 and 4 show more stability and less variation. Therefore, they are good candidates. Racer 1 more than Racer 4 in my opinion. Racer 2, although the best performer, at least in the short term, seems to take more risk and show more variability in his racing pattern. So this may suggest that he may not be able to keep up his performance. Racer 4 is perhaps the least optimal choice. Very tight and has a distribution very well distributed and symmetrical, so to speak. But he may be what we call the good loser. So very consistent, but doesn't look like he's going to win anything at this speed, literally speaking. So there you have it. That's our quick comparative box plots analysis. We can visually see what's going on with different races in this case. You can apply the same analysis to different scenarios and all sorts of data if you want to have a quick visual of what's going on between, in this case, the 4 racers. But you can have a quick look at the distribution of the data, the outliers, and how well centered the data is, and how distant the median and the mean are from each other, and have a very good idea of what's going on with your entire data set. So I hope you've learned something here today, and I hope to see you next time.